So another use of z-test is to find out whether there is a significant difference between proportions. So first of all, there will be a question that what is proportion. So imagine there was again the hospital with 20 babies, out of which 5, those who are marked in red, were low birth weight. So if the question is asked where you have to find out proportion of babies who were LBW, so you can find out by using number of LBW babies upon total babies. So in this question there are 5 LBW babies and total babies are 20. So it will be 1 by 4, which is 0.25, and proportion can also be represented in percentages. So it will be 25%. Okay, so now z-test. So the use of z-test, as I said earlier, is to test the significance of difference in proportions. Now first of all we will mug some formulas. This formula is the z formula for proportions. Now SE refers to standard error of difference between proportions. It can be calculated by this scary looking formula, but it is not really scary once you practice twice or thrice. And the P is actually capital, not small one. It is different from this P1 and P2, which can be calculated by this formula, and Q is 1 minus P. So we'll take another problem and we'll learn the steps as we go through. So there was a random sample of adults which was examined for presence of guinea worm infestation prior to health education for sanitation. So before health education they compared the number of people who were having guinea worm infestation, which were 175 out of 2500, and after the health education we expect that people would have less infestation. So after the education program they choose 3250 people, and out of those 192 were positive for guinea worm infestation. Now we are asked to draw the inference by calculating appropriate statistical test. So basically they are asking us whether there was significant difference between people who had guinea worm infestation before and after health education program. Now for step 1 again we will use null hypothesis. What will it be? The proportion of 1 and 2. Now 1 is for before a health education program and P2 is for after the health education program, and this proportion is for people who are infested with guinea worm out of total sample. So for null hypothesis we will assume that there was no significant difference and it will be equal, and for P1 not equal to P2 will be our alternate hypothesis, because we are asked to find difference. Now in step 2 we will calculate all the various things. For P1 there were 175 people out of 2500, and for P2 there were 192 positive out of 3250. So it will be around 0.07 and this will be around 0.059. You can also choose it to be 0.06. Now calculating capital P, so you can put P1 as this value, it will be easier to calculate. N1 is 2500, P2 will be 192 upon 3250 in total. It will come to be around 0.064, and this will be 1 minus 0.064, which is around 0.936. Next step we will calculate standard error. Standard error is equal to standard deviation of sample, but it is for population. So 0.064, 0.936, 0.2500, 3250. This will come around root of 0.4042, which is about 0.0065. Now putting the value here we will get 0.07 as we saw here. Now sample size N1 and 2 are sample size, so this is N1, this is N2. So 2500, 3250. 0.059, and standard error is from here 0.0065. This will give us value of positive 1.69. Okay, now you can also calculate by directly calculating both of this in one single equation, but you can be more spacey. By this way you will reduce the chances of making any mistakes. The next step 3, is again same as the z-test for parametric use. The comparison with tabloid value. Tabloid value for 95%, as I told you before, will be 1.96. Now as we can see, 1.69 is actually lesser than the tabloid value. That means that our hypothesis was actually true, so it has to be accepted. In normal distribution curve, the value that we got is actually here, somewhere here, 1.69, and the highest value is 1.96. So this is 95%, and because this value is somewhere here, we will consider it as non-significant. So it is non-significant, and H0 will be accepted, which means that P1 is equal to P2, or there isn't any significant difference, no significant difference between the people who had infestation before or after health education program. So this way we can calculate significance of difference between two proportions. Now for a sample problem, for practice problem, you have in a random sample of 1000 people from Delhi, 500 were rice consumers. In another sample of 1200 from Mangalore, 650 were rice consumers. Now at a significant level of 5%, you have to find out whether there is a significant difference between proportion of people who take rice in their diet in Delhi and Bangalore. Now the answer will be in description, so please check that out.